So this video is a continuation of working with scientific notation. To be able to do this, you'll need to know how to do scientific notation because you go from one form to another. Prefixes, it's another way to represent very large or very small numbers with in a short form. In this case, instead of the powers, we use assigned letters called prefixes. You'll probably be familiar with some of them already. If we look at this, here's your standard 10 to the 1. That's 10 to the 0. That's kind of your base. That's the value 1. And then if we want to relate it to that 1, we can use exponents. So for example, we could go to 10 to the 1, 10 to the 2, 10 to the 3, right? That's times 1,000. And we know that 1,000 is kilo. So kilo represents 1,000. Just like hecto represents 1 times 100s. If we want to go the other direction, something you're familiar with these two, right? Centa, that's going to be times 10 to the negative 2 compared to 1, right? That's 100th, or so 100th, and milli compared to 1, that would be 1,000th of a meter, and so on, right? So these relates the name to the prefixes to what the prefix represents as a value, the power of that. Okay, so what we can do, I'm just going to clear this mess up a bit. So we can work on the next page. So first of all, we're going to go from converting numbers in scientific notation to prefixes. This should say standard form. We go from standard form to scientific to prefixes. So I'll show you how that works. So for example, let's say we want to write 4,000 meters with the proper prefix. Well, we know that's 4 times 10 to the 3 meters. And then we go and we look and we say, okay, well, what's 10 to the 3? 10 to the 3 is right here. That prefix is kilo. So 4,000 meters, that makes sense. That's 4 kilometers. We've represented that standard number with the prefix kilo. Okay, so we go from standard to scientific to prefix. So this is standard, sci notation, and this is prefix notation. And so here's just another example. So here we have 3 times 10 to the negative 3, 6, 7, 8. Oh, oops, 9. Sorry, 9. Right? And now what we do is we look for what this is. This is a common one in physics. 10 to the negative 9. In physics, this is actually one of those common ones you want to remember. 10 to the negative 9 is nano. Nanometers are fairly common. It's a fairly common time unit, and it's a fairly common length unit. So 3 nanoseconds. So say you're reading a physics textbook and you come across this here, you should know, well, that really represents this value, 3 nanoseconds. A lot of people get stuck on that right away. Okay, 47,000 moles, so this is more of a chemistry thing, but so 4 8.7 times 10 to the 1, 2, 3, 4. Now let's look back for 10 to the 4 in the prefix. We go up. Alright, so that's a problem. 10 to the 4 is in between mega and kilo. So we have to decide what we want to do. Do we want to go up to mega, or do we want to go down to kilo to show it as a prefix? So what I'm going to do is I'm actually going to reduce this exponent. But if I reduce this by a factor of 10, oops, sorry, just give me a sec. I didn't actually reduce it. 10 to the 3. Okay, so I reduced that because I know 10 to the 3 is kilo. So I can write it like this. But if I've changed this, if I've divided this by 10 to make this exponent 1 smaller, what I have to do is I have to balance it and I have to times this by 10 to make it 1 power 10 larger. So my answer is 47 kilomoles. Now let's say I want to, let's say instead I want to go from 4.7 times 10 to the 4 moles to megamoles. So that's 10 to the 6 is megamoles. So what I've done here is I've times by 10 by 10. I've times by 100. So what do I have to do? I have to divide by 100 here. And I get 0.047, which is 0.047 megamoles. Okay, so sometimes you get stuck in an in-between power that doesn't have a prefix readily associated with it, and you could switch to one quite easily. You just make some adjustments. Alright, going from prefix to standard, we're just doing the exact opposite. Place the prefix with the power, and then we go from that to standard notation, from scientific to standard. So 8.9 nanoseconds. So nano is, we can look on that chart, times 10 to the negative 9 seconds. Now we can change that to scientific notation. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So 0.1, 2, 3, 4, 5, 6, 7, 8 zeros. Then my non-zero digit, that's the 9th place, and then the extra 9 there. 3 gigabytes. So that's 3 times 10 to the giga is here, here. That's times 10 to the 9. As soon as I take that G off, right? G is times 10 to the 9. That's what it represents. So that's going to be 3, 1, 2, 3, 4, 5, 6, 7, 8, 9 bytes. Okay. And then I have 7.56 picometers. That comes up in physics occasionally. So again, 7.56 times 10 to the what meters. Let's look for it. Pico. There's the P, pico, times 10 to the negative 12. Alright, so 7.56, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Alright, so there's going to be 11 zeros and then the 7. And put my unit at the end there. Okay, so that's working with prefixes. They often come up in textbooks. They're used to communicate large numbers in a short, concise fashion. But if you don't know how to work with them, well, you kind of get stuck early on in whatever you're trying to do. Here's some practice working with those prefixes.